In this last video, we're going to take a look at how we can use another algebra technique to kind of help us when a trig substitution may not be kind of ready to be applied to a given integral. So if you take a look here at the integral that we have, you can see that underneath the radical in that denominator, we have something that's really kind of messy because ultimately it's got three terms. And that's going to make doing a trig sub really messy. Remember that typically what we wanted is that the stuff underneath that radical, we wanted to simplify, into like a 1 minus a sine squared, where we had an identity, or a secant squared of theta minus a 1, right? Something that was easy to work with. But if I have to replace something with x, or replace x with something, it's going to be really hard to get to something like this in the current form. So what we're going to try to go ahead and do is to use the process of completing the square to perform a substitution. Now it's actually probably been a long time since you've dealt with completing the square. It's one of those topics that a lot of people tend to forget, but we'll quickly cover it here. So I'm going to say that our goal is to really try to calculate or to rewrite this expression of 3 minus 2x minus x squared. And we're going to do that by performing the process of completing the square. Now the first thing I'm going to do is I'm going to just reverse the order here. I'm going to write this in descending order. And I'll note that in order to complete the square, what we often are going to be doing is to separate out the items that have x's in them from the items that do not. We're also going to make sure that the leading coefficient of the x squared term is positive. And then we'll make some room to kind of introduce something into our expression. Now I can't just put anything in the world that I want in here, and so if I do put something here, I'm going to have to kind of counterbalance it over on the side. Now you may happen to recall that it's to figure out what I want to put in this blank, I have to take the value of b over 2, and I typically will square it, where b is the value that's coming right here off of the x. So in this case, I'd say, what is 2 divided by 2? That's 1. And when I square it, that means that I'm going to be interested here in just adding a 1 in. Now, of course, when I add that 1 into the expression, that would be like going here and just adding a plus 1. And I can't just add a plus 1 to something, but I can add a 1 and then take it away. Except that what I just wrote down there is slightly inaccurate, because I didn't really add a 1 over here. Notice that if I redistribute the negative, I really put a negative 1 over here, which means to counterbalance it, I would have to put a positive 1 over here. Negative 1 and positive 1 will cancel out. But the purpose of doing all of this is that now I can rewrite this quantity as an x plus 1 all squared plus a 4. And if I want to rewrite that one more time, I could express that as 4 minus x plus 1 squared. If I now think about what I have, my integral, which used to look like this, can now go ahead and actually be slightly rewritten. So using what we just found, I can go ahead and replace what I have under the radical with a 4 minus that x plus 1 all squared. Now, this form looks a little bit closer to what we had with our regular trig subs. I could actually now imagine doing kind of a interesting trig substitution. I could imagine, instead of just replacing x, what if I replaced x plus 1 with something? Right? Like if I took out all of x plus 1 and I put something else in its place, I could imagine maybe putting in a 2, because when I do 2 squared, I'll match the 4. When I pull out the 4, I'm going to have 4 minus, or 4 times 1 minus something squared. And so maybe something like a sine of theta here could be a great choice. Notice that I can actually take this then and easily convert this into really just what I'm replacing x with. I'm really just replacing x with 2 sine theta minus 1. And so it would be very possible to get dx by just doing 2 cosine theta d theta. So with this and swapping out my bounds, I'd be able to actually complete this problem with no issue. Now, I'm not going to go ahead and finish this problem all the way off, as that wasn't really the goal. But you can see here that by using this process of completing the square, I can take something that's ugly and difficult to work with and convert it really into an addition or subtraction of two terms, and therefore making a trig substitution again very, very possible.